Hey everyone, quick back Mr. Basics here. Let's talk about electron microscope. Well, this is a wonderful topic to study. It got a Nobel Prize in the year 1986 and again in the year 2017. The electron microscope was invented because of the drawbacks of light microscope. One of the major drawbacks of light microscope is the phenomenon of diffraction limitation. So, let's try to understand what is an image formed by the microscope and how it is affected by the phenomenon of diffraction. If we understand this, it will be very easy to understand the working of an electron microscope. So, keep watching. For example, when light passes through a slit, it gets diffracted. So what you see is the central maxima, first order minima, first order maxima, and so on. Now, if we have a convex lens in between, then the lens collects the diffracted light and focuses it on a screen. This results in the formation of the image of the slit. So the image is nothing but an interference pattern of the diffracted light. Now, a very important point to note over here is that it's the edge of the slit that diffracts the light. So to see the edge of the slit clearly as an image, the lens must collect the diffraction pattern. If the lens fails to collect the diffraction pattern, the image formed is blurred. Now, as the width of the slit decreases, the diffraction increases. Soon there comes a point where the objective fails to collect the diffraction pattern. When this occurs, the image formed is blurred. A similar phenomenon occurs when we try to see the small specimen with a microscope. As the specimen size decreases, the image gets blurred. The resolving limit of light microscope is given by Abbe's equation, and according to this value is roughly 200 to 250 nanometers depending on the wavelength of light used. The red light suffers maximum diffraction because of large wavelength, and hence resolution obtained is low, while the blue light suffers less diffraction because of short wavelength, and hence resolution obtained is high. So the idea is, if we have less wavelength, the diffraction will be less and resolution will be high. In the year 1924, French scientist Louis de Broglie gave a beautiful concept of matter-wave equation. According to this, moving matter can have a wave nature associated with it. This was experimentally proven in the year 1927 using electron beam as a source of particles, and they did behave as waves and formed a diffraction pattern just like photons did. Now, because the mass of electron is much more than the mass of photon, the wavelength of electron beam will be much less than the ordinary light of photons. Ernest Ruska realized this in the year 1933 and invented the first electron microscope. When the electron beam behaving as a wave hits the tiny specimen, it does suffer diffraction. However, the diffraction is less as compared to light of photons. Now, as the diffraction is less, this can be easily collected by magnetic lenses to give rise to clear, sharp image of the specimen. Let's see the construction of transmission electron microscope. The transmission electron microscope has an electron gun as a source of electrons. As the moving electrons have magnetic field, they can be easily focused using electromagnetic lenses. Now, just like an optical microscope, TEM has a condenser lens, objective lens, and a projector lens. However, these are all electromagnetic lenses. Electrons are focused on the specimen using the condenser. The diffracted electrons by the specimen are collected by the objective lens. The electrons from the objective lens moves to the projector lens, which projects the image of the specimen on the fluorescent screen. In transmission electron microscopy, the samples are usually stained with uranyl acetate. Now let's talk about scanning electron microscope. As the name suggests, this microscope scans the specimen and gives high-resolution images of the surface. The SEM consists of an electron gun as a source of electrons, condenser lens, an objective lens which focuses the beam of electrons on the specimen. The scanning coil usually scans the electron beam in X and Y direction. The specimen is coated with heavy metals like gold, platinum, iridium, chromium, and tungsten. The presence of these heavy metals on the surface allows the electrons to be scattered. The scattered electrons are detected by electron detector, and finally information about the surface of the specimen is obtained on the computer. Now let's talk about cryo-electron microscope. X-ray diffraction have been one of the long-term dominant methods to obtain information regarding crystal structure of protein. In this method, X-rays are allowed to pass through crystallized protein and the diffraction pattern is obtained. Using the information in the diffraction pattern, the location of each atom is deduced to obtain the protein structure. However, the major drawbacks of X-ray crystallography is that proteins need to be crystallized, and crystallization of proteins is very difficult. Because of these drawbacks, people started searching alternative methods to obtain 3D structure of proteins. This was cryo-electron microscopy. In this method, a beam of electrons is fired at a frozen protein solution. As the electrons get scattered and diffracted, they pass through electromagnetic lenses which creates magnified image on the detector. An interesting thing to note over here is that the frozen protein solution can have protein molecules in different orientation. Hence, while taking multiple images of protein molecules in different orientation, a 3D image of protein can be obtained by combining all images using a software.